Hello there, welcome to this video presentation. In this video, I will walk you through our machine learning assignment. First of all, let's get to know the domain. The basic idea of this assignment is to build a model that can be used for movie recommendation. Predicting the main concept is to predict the user's rating on the movies that user has never seen before. And how does it work? It depends on user's past rating. For example, if someone gives high ratings to, let's say, action movies, then we can derive from that. Then he might give high rating to other action movies as well. So that's just a basic example. For the purpose of this assignment, we gathered the data from a website called GroupLens. Let's get to explore the data a little bit more. The data has three files called, the first file is called movies. The movies has a movie ID, the title of the movie, and the genres it belongs to. The second file that we have is ratings. The ratings file consists of information of which user gave what rating to which movie. We also have data that's known as tags. The tagged data has information about which user has given what tag to which movie ID. So a tag is basically a small word or two words or three words, a small explanation or a small reaction of a user to a movie. Okay, so after knowing the data, we move on to some early pre-processing of the data to make it suitable for our machine learning model. One of the interesting pre-processing that we did could be this, where we converted this movie's data that had genres as an array to a data frame that has genres as columns. So how we can see it is that each of these genres has been split into their own columns. Like here, the action and adventure here are their own column, and the movies that are inside action genres have one value in this column, and those who don't have 0 values on this column. So, for example, here we can see that Toy Story falls inside the genres of adventure, animation, children, comedy, and fantasy. So this will mean that the columns adventure, animation, children, comedy, and fantasy will have one value for Toy Story, while 0 value for other genres. So let's move into some of the interesting and insightful visualizations of the data that we have. The first one we have is genre by popularity. From this nice bar graph, we can see that drama and comedy genres have a lot of movies in our database, a lot of reviews in our database. While documentary and film noir are, as we can see, niche categories, they have really low number of reviews. So now if we look at the average rating per genre, the film noir and documentary that were really on the lower spectrum of popularity are on the higher spectrum of average rating. This might mean that those who like to give rating to these niche or those people who are into this niche genre really, really enjoy them and tend to give higher ratings. This could also be correlated with the fact that comedy and horror having high number of ratings and different, there are higher range of movies, so some movies can get really bad reviews, uh, and dragging down the overall average rating per genre. The next one we have is a box plot that shows a variations in number of ratings by movies. We can see that a lot of movies have less than 25 reviews or ratings, while there are few movies that have insanely high ratings, more than 350. So this means that our data is right skewed. So we have to use a log transform to somehow compensate or correct that. So now we can see from the data that instead of having from 0 to 50, now it ranges from 1, 2, 3, and 4, meaning that the skewness is lowered down. This might help our model later on. So let's look inside the tag data. So here's a nice word cloud that explains how the different word inside the tag data. It makes sense that the tags are somewhat correlated with genre, like dark, comedy, funny, provoking, and surreal, suspense, and etc. So let's look inside the tag stats. A really important stat that we found is that there are 7,913 movies that have no tags and 131 tags with no corresponding movies. Since we have 9,485 movies and more than 3/4 of the movies have no tags, for us it didn't make sense to include this data as a feature, because that will just mean most of the data, most of the movies just going to have nance field, which is not good for a machine learning model. So we should not merge the tags to our feature columns. So unfortunately, we had to completely discard this data. We also came to notice that there are some missing genre values. There are 44 movies without genres. So we thought about maybe pulling the genres from IMDb and then handpicking them into database. But since it's only 44 and we already have like 10,000 movies, we just decided to drop them from the dataset. And we also ran into this one issue. Some of the movies had only one rating. So, for example, some movie would have only one rating, means only one user have ever given the rating, and it will really be extremely biased to use that data to represent the movie. For example, if a movie named A has one review, this movie is really bad, but for some reason one user gives it 5 stars, then it's not really trustworthy. That's why we also decided to drop them from our dataset. After this, our feature data was ready, and if we look into the correlation metrics, we can see that the data are really independent of each other, which is also a nice sign or nice indication, or basically a nice data to feed to a machine learning. The next task in hand was to split the data into training and testing. We used the train test split function to do that. The first approach was to use a linear regression model to predict the user rating, and following were the results of it. A mean squared error, we got the mean squared error of 1.023. 1.012 root mean squared error, mean absolute error of 0.86, and R squared of 0.044. So since the value can be 0, 1, 2, 3, 4, 5, having a mean squared error of 1.023. Oh, sorry again. The values can be from 0 to 5. So, and then having a mean squared error of 1.023 was really concerning because we would like it to be lesser than that. So we tried another machine learning model called Random Forest Regressor. It performs slightly better, but it's not what we were big fan of. We use something called SVR with standard scalar, and this is also in the similar reasons. Then we used the SVD model, singular value decomposition model, and it performed the best among them with the root mean square error of 0.87 and mean absolute error of 0.67. We thought of combining all the models, but it really didn't help much as we had a decent results here with SVD model as well. So for now, we are settling with the SVD model, which gives the mean squared error, which gives the mean absolute error of 0.67. So the basic conclusion of this was maybe we should have used other datasets to get more features because of the R squared error being the R squared value being really low. Combining the model had a little bit better of it, but again, it wasn't the best. And it was also very unfortunate that the DAX dataset that we had was completely unused due to the extreme inconsistency of it. So we think if we could have squeezed in more features, then the video would have been, sorry, not the video, the model would have been much better. But for now, we can get the users, predict the user sorting rating, and it's off by 1. So it means that if the actual rating was 3, then our model might predict something along the lines of 3.8 or 2.2. But since the model was not developed to predict the rating, but to use the rating for recommendation system, we think it might still be useful. So that was the end of the video. Thank you for watching and have a nice day. Bye bye.